Planetary ring systems are among the most striking and beautiful structures in our solar system. Yet they are also delicate and complex. At their core, a ring system is made up of countless particles, ranging from fine grains of dust to chunks of ice and rock, circling around a planet in flat, disc-like bands. These particles are locked in orbit by the planet's gravity, creating a shimmering halo that can stretch for thousands of kilometers, though often only a few meters thick. The most famous example is Saturn, whose rings can be seen even through a small telescope from Earth. They consist mostly of water ice, giving them their brilliant, reflective appearance. But Saturn isn't alone in this cosmic adornment. Jupiter, Uranus, and Neptune also host ring systems, though theirs are much darker and more difficult to detect. Even tiny dwarf planets like Haumea have been found to possess rings, reminding us that this phenomenon isn't reserved only for the gas giants. The origins of these rings are fascinating. In some cases, they may be the remains of shattered moons. If a moon wandered too close to its planet, it could be torn apart by tidal forces inside what's known as the Roche limit, the distance at which gravity overcomes the moon's own strength. Instead of crashing down, the debris would spread out into a disk, forming rings. Other ring systems may have formed from material left over from the early solar system, remnants that never coalesced into full moons. Collisions between existing moons or asteroids also contribute fresh material, constantly reshaping the structure of the rings. Despite their size and grandeur, planetary rings are incredibly thin. Saturn's main rings, for instance, span more than 280,000 kilometers in diameter, but are usually no thicker than about 10 meters. This thinness highlights how delicately balanced the particles are, kept in place by a mix of gravitational interactions and the presence of small, shepherd moons that help sculpt and stabilize the ring edges. These moons act almost like cosmic guardians, pulling stray particles back into line and maintaining the ring's sharp boundaries. Ring systems are not static. They are dynamic environments where collisions, gravitational tugs, and electromagnetic forces continually shape and reshape the landscape. Over time, some rings may fade as particles drift into the planet or clump together to form new moons. Others may grow more complex as fresh material is added. This makes ring systems not only visually spectacular, but also scientifically valuable, offering astronomers clues about planetary formation, orbital dynamics, and even the processes that shaped the early solar system. In many ways, planetary rings are natural laboratories suspended in space. They reveal how gravity sculpts matter into orderly structures, how destruction can lead to beauty, and how even in the vastness of the cosmos, fragile patterns can persist for millions of years. To gaze at a ringed planet is to see both the violence of cosmic collisions and the artistry of celestial order woven into a single breathtaking sight.